Okay. So we're going to talk about architecture. Has anyone here studied application architecture? How to architect a large software program? Has anyone studied that already? I'm just curious. I'm not going to pick on you. I'm just curious. Has anyone studied how to kind of break this really large task of making a software program into smaller chunks? Okay, one person. Okay, great. Okay, so let's let's leave the programming word for a second, and you've probably heard the word architecture in a different context, buildings, I'm assuming. Everyone has heard that before? All right. So what does an architect do? So if you build a shed in your backyard, are you going to hire an architect? Probably not, no. But what might you do? So if you've never built a shed, you'll probably look at other sheds that other people have built, right? So you might go online, maybe you're driving around the neighborhood, and you're going to see, okay, so I guess sheds need doors, good. I'll do that. Maybe a window, roof is probably good. What is architecture, what is the study of architecture in buildings? So you want to make sure that your building is safe, doesn't fall apart. And how do we do that? So we look at mistakes that happened in the past. So if maybe someone only put 2 walls and no cross bracing, maybe in the past a wind gust might have blown over that shed or that house. So we learned through mistakes that it's maybe a good idea to have maybe a 3rd wall or some cross bracing. We can learn from other people's mistakes. We can learn from other people's really good ideas, we can build something really complex by kind of just breaking things down into smaller components, and then having, in the case of an architect for buildings, having one person who's an expert at that, and then they can kind of plan the whole thing, and then we can hand off the work. So in applications and software applications and programs, we kind of have a similar thing going on. So what's the equivalent of trying to build a shed in your backyard? Maybe you have a bunch of grades, and you see yourself every year, or maybe not grades, maybe you have a job, and you want to have a good way to calculate maybe your taxes on that. So if you want to build a little quick program that just calculates the tax, you wouldn't need to hire an architect for that. Maybe you can just write a little program where you type in some numbers and it spits something out. But you might still go out and look for inspiration somewhere else, so you can learn there. But then if you work at a company where you're working with maybe 100 other engineers, you have to have a common language. You have to be able to talk about the same things, and you have to with a really large software application, a lot of things can go really wrong. So if you have if you can learn from the past, if you can learn from mistakes that other people have made, that's also really good. So one thing that architecture allows us to do is learn from other people's mistakes. And then, if you have and good ideas, so there's so if you solve the same kind of problem over and over again, there might be a really good solution for all of them. So in buildings, my stuff gets wet. Okay, so a roof seems like a good thing to have. So maybe in all the places where it can rain, maybe it's a good idea to always maybe start with a roof. Like we'll have a roof on our house. So yeah, in large applications, maybe security is maybe a thing that if you write a big web application, keeping people's passwords safe, we probably don't want to have everyone reinvent that. We probably want people to kind of learn from the mistakes that happened in the past, and then not have to reinvent the wheel over and over again. So yeah, learn from people's mistakes, learn from good practices, and then what else does the architecture allow us to do? So if I build a skyscraper, we're gonna have maybe thousands of people working on this thing. And if we didn't have a way to coordinate everyone, then I'm gonna assume we're gonna end up with not a skyscraper. So if everyone kind of just does what they want to do, that doesn't work. If everyone comes to you to decide, so if you have 1,000 people coming to you every morning and they're asking, what should I do today? And and then maybe you're telling someone, today you're gonna put some steel beams over there, and then the next person comes, what should I do today? Today you're gonna pour some concrete there. So then you have this one person as a bottleneck, one person knows all of the information, maybe you're inventing new things every time you're building this, so that is also gonna take a really long time. But yeah, so if we develop a common language, so maybe you can hire a carpenter, and the carpenter can do all of the framing of wooden things. You can maybe hire someone who's an expert with steel, and they can do all the welding. Maybe you hire an electrician, and they're going to do all the electrical work. And they're going to get really good at that work, and then they even if maybe they don't like to work for you anymore, they're going to go somewhere else. They already kind of know, okay, so normally, so electrical cables for lights probably should go into the ceiling. So you can learn something on one project and then bring it to the next project. So we can split up work really easily. And how is that possible? So we have a common language. And if we can kind of create modules, so you work on Windows, you work on electrical work. So if we can kind of modularize the work, then it's much easier to plan. It's easier to, if you have an expert at putting in Windows, they're going to be able to tell you much better when they might be done. Okay. So yeah, that's kind of same thing with buildings. The building of a large software application can fail if you don't have a plan for how to do things. And yeah, so there's really small projects where if you're approaching it the same way as a skyscraper, you're probably not going to get anything done. And then there's really large projects. If you don't plan ahead and have a good idea of how you're going to do that, then that's probably also not going to happen. So there are some architecture patterns that are pretty common. So for UIKit, the architecture pattern that was forced onto everyone is called MVC. And this stands for Model, View, Control. 2 L's? I forget. Controller, 2 L's. Yeah, I think 2 L's. Tell me if I'm wrong. Model, I'm missing an L here. So model, view, control. So if we're building an app using UIKit, we are forced into this pattern. we can kind of go a little bit rogue and misuse the pattern, but at least we're forced to follow the general principles of this. Otherwise, we can't do anything. And so on top of this model, view, and control, there's a ton of other patterns that you can do on top of it. But so if you're building in UIKit, you're at least starting with MVC. So on top of this, you might have MVVM, which stands for model view view model. So model view view model. So this one is very closely related to MVC. I will talk about how it's different, why it's used. And then, so there's MVP, which you'll see in a lot of Android applications, or older ones at least, MVP, which is model view presenter. And don't worry, I won't ask you any of these. MVC, you'll learn for sure, and we'll talk about the components, but the other ones, not so much. So yeah, MVVM, MVP, there's lots of other ones. One that I haven't seen outside of iOS applications is called Viper. So this one, I think the R stands for routing. So this one creates like more little sectioned off domains that are responsible for very specific things. So the way that you navigate has its own component, which is interesting. But yeah, so there's some other ones. We'll talk about MVC today. A little bit about MVVM also today and a little bit later, and then we'll see what we might do in SwiftUI. Okay, so what is this MVC? So I like to draw this diagram for this. So we have the model, we have the view, and then the control or the controller. These are the three components that we have. Let's cordon those off here, and let's see how. So one way that we can get a sense for what this even is, we can talk about what are the responsibilities of each of these components, and then how do they talk to each other. So the view is probably the most clear. So what is the view in an application? So we have something that the user can interact with. So see, maybe touch. So the jobs of the view are to respond to user input. So if someone is dragging on a view, we might want to know about that. If someone is typing in a text field, we want to know about that. Maybe rotating. So those are all responsibilities of the view. Recognizing them, maybe not respond, but yeah, maybe let's say recognize, not respond. And I guess we don't need the two. Okay. All right. So then, to lay out some, to create the user interface. So to maybe show the user some information. So display. I'm going to say stuff. We'll talk a little bit more about what we'll be displaying. And then one other job of the view in the MVC pattern is it's responsible for laying out subviews. So you might have a big parent view, and then the parent view says, okay, there's a text field here, there's a button, which is also a view here, and then maybe a picker here. So that's also a job of the view. Okay. And then, so we have the model. Who's heard the word model before? And you might have heard it in different contexts. So here it means something pretty specific, but who's heard the word model before? Yeah. What contexts have you guys heard model before? Yeah, yeah. Yeah, so there the model is kind of the big, so same with scientific models. So if you might have a model that can do weather predictions, you can have a weather model. So those are big, complex machines that give you something. Who's heard model maybe in a different context, yeah?
Like a minifigure, like a small.
Oh, yeah. Yes. So, who's heard of it in the computer science environment? Good one though. Yes. Uh-huh. Yeah. Yeah. Okay. So I'm gonna pick one of the things he set up there. So data. So yeah, there's lots of different definitions of model. The one that we are interested in for MVC has a pretty specific meaning. So what are its jobs? In MVC, one of its jobs is to contain data. So that's exactly what you said. So if we have a database with a lot of stuff in it, so talking to that database or containing the data maybe is the job of the model. So one other job, and then so in certain applications, that is all the model does. So in MVC, we also do operations on that data. So if we're doing computations on the data that the model contains, that's also part of the of that model. So here I'm going to say contain data, and transforming or working with that data. So I guess working with that data. Working, transforming, calculating with the data. Okay, so yeah, view, very specific jobs, user input, displaying information, laying out subviews, model, contain data, and then operations on that data. So calculations, removing data, kind of managing that. Okay, so one could say maybe, okay, what else? Why do we need something else here? So those two seem to do most of the things that I want. Why don't we just have them talk to each other? So one downside of just having a model and a view that talk to each other is your app. Anything that you write will be very specific to the way that we're displaying it. So if you only have a model and a view, then there's going to be some code for talking directly to a specific model from the view and getting something from a very specific row in your database, maybe deleting something very specific there, and then vice versa. Maybe a model might want to tell a very specific view that it updated. So you kind of end up with this scenario where you can't really reuse your models anywhere else, and you can't really reuse your views anywhere else. And that might seem fine at first, but then we've already reused some view components. So we've reused buttons, and we've reused text fields. And if the buttons were tied to a very specific database that they can talk to, so if I press this button and it deletes a row from a very specific database, that wouldn't be very useful. We wouldn't be able to reuse that very well. So this brings us to the controller, or in UIKit land, the view controller. So what are the jobs of the view controller. The main job is really to facilitate communication between a view and a model. So it's the glue between a view and a model. And so the view controllers are the very customized thing that makes those two be able to talk to each other. And so the views we try to build in a very general way that we might be able to reuse them elsewhere, and the models we are building in a way that other views might be able to use them as well. So I'm going to say as the main job, facilitate talking or talk between view and the model. So yeah, I've said the glue, the thing that makes those two to talk to each other. And then, so for MVC, it also has the job of causing, of causing the view to change. So if we want to animate something, if we want to hide something, so one of its job is also to here, let me move this down a little bit so we can write that, because we also want to write one other thing. So yeah, tell the view to update itself, animation, so I'm going to say manipulate the view. And what is it basing all of this manipulation on? It's based on changes in our models. So based on changes to our model. Okay. And then one other job it is to, and these kind of fall under the very first point here. It is to update the models, so update the data based on things that the user does. So update models based on input from the viewer. Okay. So yeah, those are the jobs of those components. So view, I like to use the description dumb. So views are supposed to be dumb. They're supposed to not really think for themselves. They're supposed to just be as devoid of logic as possible. So if I can create a view without any logic in MVC land, that would be great. All of the logic would live in the controller. And then yeah, we hand everything off to the controller, which will then communicate with the model. Model, contain data, work with that data, perform operations on that, and then the controller talk between the two. Any questions here? Has anyone seen this before? MVC, this pattern? Okay, so let's maybe just create a new project real quick, and then we'll just create the project that we're going to be working with. So if we're going to use UIKit, it only works as an iOS app. So we can't create a Mac app, Watch app, or any of these other apps with UIKit. It only works for iOS. So let's choose iOS. We've been choosing multi-platform app, and then we'll do tip calculator UIKit. Oh, and then I already have, let me delete that real quick. All right, so let's see if we can find any of these components already in our app here. So one of the file names already kind of gives away one of the components that we've described, which one is that? So we have our files in our app navigator here. We have the view controller, right? Okay, so the view controller is the glue between a model and a view. So what is the view in UIKit? So we can create views programmatically, but how have we, so we've only created one little tiny app in UIKit. What did we use to create the views in UIKit? Does anyone remember? Did we write code for it, or how did we create the views? Does anyone remember? I think first lecture that we had, yeah? Plus button, yeah. And then, so we dragged stuff onto this main file, which is, let's look at it real quick in Finder. It's a .storyboard file. So the storyboard contains our views. So we have our views here. So if you're creating a default project with UIKit, your views are going to live in storyboard land. But again, that is not necessarily a given. We can also create them programmatically. All right, so where here is now, is there a view here that we can see? So we have the word view controller up here. So the view controller, this is the bar that, this is the view controller. Let's also bring up our view inspector here. So this is the, if it's not there, it's the very leftmost little toggle. Let me also make this a little bit bigger. This is our inspector here for our views. So we have our view controller, and then the view controller, under the view controller is a view. So if I highlight the view controller, it gives me the bar up here. If I highlight the view, it gives me this this phone-looking thing. And then we can expand that, and there can be other things there. So yeah, the view in a UIKit app is visually represented in Interface Builder, and we can visually drop things on there and build it that way. But again, we can also do it programmatically, and we'll see that as well. Okay, so we have two of these. So we have the view controller. We saw that. It's this file here that we have. We have the view. So the view controller owns a view. So we have a view here. And oh, that's actually another good thing to just add to our jobs here. So it owns views, and as we'll see later, it also owns view models. Sorry, models. So it has variables that that allow us to, yeah, it holds on to those. All right, so we've seen views, we've seen a view controller. We have not seen a model yet, so we'll do that. So for the calculator app, the model will be very simple, and one could argue it's a little bit overkill to create a model for this little tiny application that we're creating. But yeah. Okay, so we've seen views, we've seen models. Have we seen the view controller talk to the view? Is that something that we've seen already in our very first lecture? And how did we have that? How did we facilitate the view talking to the view controller? Does anyone remember? Even if you don't remember the exact details, how did we make them talk to each other? Does anyone remember? We dragged. Okay, so let's, what component did we drag? Does anyone remember? Button. Let's put a button on there. So let's drop a button on here, and then so we control drag, right? And where do we control drag this? To the code? Say again? Into the view controller, very good. And so if I let go, we can create an outlet or an action. So let's start with an action. And then I'm just going to say button pressed as the name for this action. And so now we've connected the view and the view, the new view that we threw on here with our view controller. our original view also now did a new thing. So we put a button on there, right? So the view controller's main view here is the parent view. And one of its jobs now is to lay out this other button that we threw on there. Yes?
So it's called view controller, right?
Yes.
So I'm assuming there's a model control by controller. I'm assuming somewhere maybe. So does that mean like the controller, as you said earlier, owns this view and therefore it's view controller and there's a model controller?
So I actually think, so you're onto something very good there. I find it slightly misleading that it's called a view controller. So in MVC, it's called model view control. So I think controller is actually potentially a better word because it does control the model and the view. So it facilitates the talking between the two.
So the code in this case is just the controller.
So the controller is the class that we have here, the view controller, yes. The view, because we're using interface builders, is not code because it's here, but so it doesn't have to be. So we can also create code that creates a view. So let's do my view. So now we've created in UIKit, we've created a view that's in code. So here we have the controller that is code. Here we have the view that is code. Here we have the view that is laid out in XML in this case. Okay, and also this is very different from what we've seen so far in SwiftUI. So SwiftUI works very differently. So this is maybe. So why am I teaching you this other thing? I think I mentioned this at the beginning of the class. If you do end up taking a job as an iOS engineer somewhere, you are going to be working with both of these, UIKit and SwiftUI. I would say probably in a lot of places, equal amounts. The newer the places, maybe more SwiftUI. So sadly, we have to learn both. They're very different. I want to stress that. So we kind of have to almost forget a lot of the stuff that we've learned in the other lectures so far. But yeah, so good question. What is this controller? Is there a model controller? Not in this case. There's I guess a data controller later, but it's a model in my opinion. But yeah, so we have a view controller here, and it will one of its jobs is to own this view. It does have so it's hidden from us right now, but it does own this view that we just plopped this button onto. So if I'm going to command click onto the UI view controller, and one of the things that we see here, so this is this is kind of the interface for our view controller. These are all the functions that are available to us and all of the properties. And look at this. So the UI view controller has a view property. This is this view here. So it owns the view. It owns this view. And then because it owns that view, it can manipulate things that are happening here, and we can manipulate things that are child views on here. Okay, so yeah, we've thrown this button onto this view. So one of the jobs of the main view here is to lay out this button, and then now we want to be able to have this button do something. So we control dragged into the view controller, and so we've made a connection here. So what happens if we press this button? So the button itself doesn't execute any code. Where does if there's something that should happen when the button gets pressed, where does this code get executed? Yeah, so very good. Yeah, so the button gets clicked. So the job of the view is only to recognize the user input. So the button, which is a view, recognizes someone pressed me. So I need help to do something with this. So let me let my controller know. And we did that by dragging this action into existence. So let's add some, here I'm going to create another diagram here. Control, view, model. So in this case, the button gets pressed. So the button is going to let the controller know that it was pressed, right? So that's what we just did. We control dragged the button. And now if we want to execute some code, maybe let's print something to the console. Oh. Okay, so let's build this. Let's bring up the console. Let's hide this thing. Here we go. Okay, so yeah, while that is starting up here, so the view recognizes it was tapped. So the button view recognizes that it was tapped. It lets its controller know, hey, I was tapped, and then the controller can execute some code. And as you very correctly said, its only job is to kind of facilitate the talk between the view and a model. So ideally, it would now cause a model to do something. And we'll see that in a second here. Okay, no button yet, so this is still starting up. Okay, so while that is starting up, so yeah, in our little diagram that we have here, so our view talked to the controller, right? So let's create a little arrow here. I'm gonna draw this as a dashed arrow because the communication between from the view to the controller is not direct. So we're using a form of indirect communication, and the one that we're seeing here right now is called target action. Action, here we go. Okay, so this is a form of indirect communication. We'll talk about why that is in a second, yeah?
What is a direct function?
Very good question. So yeah, we press the button, and we're letting the view controller know that something happened. Somehow it is indirect. Let's see direct communication. So instead of printing hello world to the console here, let's add a label, a UI label. Here we go. And now instead of having the console print this out, we're gonna have this we're gonna present this in this label. So we added another view, which is this label. Somehow we have to make the controller aware of it. How do we do that? Again, control dragging, and then I'm just gonna call this output. And we're creating an outlet here, connect. Okay. So let's do some direct communication. So instead of printing, we're gonna tell the label, hey, this label saved in this output variable. So it has a text property. I want you to display hello world. So this is direct communication. So we have a variable that has full access to anything that this label knows or displays or thinks about. So if labels can think. So the view controller owns this label. So it's one of the views that it controls. It knows its state, it can ask it questions, it can have it do things. And when we have it do things, that is, we're telling it directly, hey, you, label, that I saved under the output property, change your text property. So let's test that real quick. And then so once we demonstrate this, okay, so the button, so what happened here? So the button recognized that I tapped it. The button let the view controller know, hey, I was tapped, and this is how it's indirect. It just said, hey, I was tapped. I don't know who I'm talking to. I was tapped. I'm talking to someone who knows what to do with this. The view controller recognizes, hey, the button was pressed. Let me talk to the label and update the label with hello world. So let me talk directly to the label and let me update what's there. Okay, so let's go back to our diagram here. So view talking to the controller, through target action is indirect communication. And then when the controller talks to the view, here, let me mix it up with some colors here. So this one is direct. I'm not going to spell it all out. Direct communication. Yes, question.
Is that always the case? Can you have a case where the view is talking to the controller and it's direct?
So that's the thing we really don't want to avoid.
Oh.
So let's take a look what that would mean. So for the controller to be able to talk to the view, it has to know everything about. So it owns this view. So it knows everything about it. So it has an instance of this view, of this label view, and it's like, okay, so it's this specific label, and I'm gonna change a specific thing about you. So that makes the view controller not really reusable, because it is the glue between a specific view and the models that the view wants to display. So the glue between the two, I think maybe if someone moves the back of the lights will turn back on. There you go. I think there's a motion sensor, so you guys were too quiet. So the glue we can't really reuse. So we're actually trying to keep the glue to a minimum. So wherever we can make something reusable, we're trying to reuse it. But at some point, we have to create something that we can't reuse. So the view controller is the glue between views and models, which is the not reusable part. Why is it not reusable? If the communication is direct, it is to a specific view. We know everything about it. So if a view talked directly to a very specific view controller, at that point the view wouldn't be reusable with another view controller, because it can only talk to one view controller. Does that make sense? Okay. So yeah. So if you have a button, in this case here, if we created a button that can talk to our I don't know what are we doing here? Oh, a tip calculator. So if we had a tip calculation button, and the tip calculation button knew how to update a specific variable on my view controller, we would not be able to reuse it anymore, because it would be updating this specific variable. Does that make sense?
Okay,
yeah. Yeah. Okay. Good. But there's a little asterisk here. We're gonna see views. It looks like views are talking to view controllers, but it's masked through. There's some additional masking going on that makes it indirect again. We'll get to that in a little bit. So we're going to see a strategy for what you are trying to do right now. We're going to see a strategy to do that in a way that we can still do it and reuse components. And kind of one thing that we're trying to do is, have you guys heard the word decouple? Have you guys heard decouple before? Yeah, so you want your code to be kind of independent. You don't want it to, so the more you have little tentacles going either direction, the harder it is to kind of separate them. So if you have your thing, if you have a thing that you can have it do its own thing here, and the other thing does its own thing, and only where it's absolutely necessary is there communication between the two. It makes it easier to reason about both of the systems. So if there's only one place where the two communicate, if there's a bug between that communication, that's the only place you need to look. So it makes it easier for us to think about all of these components. If there's a component that has only one job, we can kind of think about what is it doing? Is it doing its job correctly? Oh, it's not. We can fix it. And then we can kind of take that out of our brain, put the next component in, reason about that component, and then otherwise very quickly you get to a point where if there's too many tentacles going either direction, you have to put everything into your brain, and at some point when you're shoving something in, it comes out the other end. You can't fit it all in there. So yeah, you had a question. Yes, you can. And so the way that we would do that is one of the controllers would act like a view. So, and we'll see that today. Very good question. Any other questions? Okay. So yeah, we've seen, let's bring back the iPad here. So we've seen direct communication. Direct communication involves, there's a variable. I'm going to talk to whatever is at this variable, and I know the exact type. So if there's a, in this case, a UI label at this point. So there's an instance of a UI label at this output, I think is what we called it, variable. That is direct communication. I'm talking directly to this thing. And then this target action thing has something indirect about it. And so how does it work? Or how can we think about it? We are by having this action here on the view controller, the button knows it's talking to some view controller that can respond to a button click with a function, and it can send itself there. So UI button. So we can when this button gets pressed, maybe one fun thing we can do here is we can take the sender's title, I think, title label. So the button, what is its title right now? It's button. As I'm talking to the view controller, I can pass myself along. So on this view controller that I'm talking to, all I know about it is there's this function that I can invoke on it. And let's maybe demonstrate that we have access to the button here. So what should happen when I press button? So the button will pass itself along as the sender, and then we're taking the sender's title label's text and we're setting it to the output's text. Let's find out. Very good. Okay, so yeah, all the button view knows is there's a function that is going to be pressed, and I can send myself. So the way we can kind of think about this is, and let's move things apart. So as the programmer, we're going to paint, so this is why it's called target action. We're going to paint a little target there on our view controller, and then, actually let me use the other color, otherwise it's going to be confusing. So we're going to paint a little target there, and then from the view, so the view will shoot an arrow. So let's say we have a bow. We're going to shoot an arrow into the target. So that's how we are kind of supposed to think about it. That's why it's called target action. So when the button gets pressed, we're going to shoot our arrow. We don't know who we're hitting. We just know that there's a target that we can hit. So this makes it indirect. We don't, as long as there's a target that we can shoot at, we don't care. So we don't know who has this target painted on their back, and that makes this part reusable. The only thing we know about our view controller is we're going to shoot at this target. Does that make sense? Okay. All right. So we've seen a form of direct communication. We've seen a form of indirect communication, and I guess I didn't. Between the view and the view controller. So yeah, we haven't really seen anything model related. So to not have to draw all of these lines here, like arrows dashed and not dashed, a very common way to show that the communication directions and how things can talk to each other in a really quick way is by borrowing from road markings. So if you're driving and you're seeing the paint in the middle of the street, we're going to borrow from that. Is anyone familiar what I'm talking about? So I know there's some international students, so maybe you don't know all of the rules of the road here, but they're going to be similar to an extent. So I think so yeah, one line paintings that we might see is a solid line and a dashed line next to it. Where do you see that? A solid line and a dashed line next to it, in the middle of the road. Yeah, so you're allowed to cross, right? So you're allowed to cross this this dashed line. So you're allowed to pass. Maybe you're allowed to make a turn from it. So yeah, that's kind of what's happening here. So the controller is allowed to cross into the view's business. So it's allowed to tell the view exactly what it wants to do. So the controller is allowed to talk directly to the view. The view, if it wants to go and tell the view controller something, it's going to have to do it in some roundabout way. So it can't just go straight across the line. Does that make sense? Okay. And then so I think, so not all other, so we're going to show one more here in a second. So this one is maybe a little bit specific to the US. So if you're an international student, this one might not exist. So what happens if there's a double solid line in the middle of the road? What does that mean? You can't cross, yeah. Either direction. So yeah, you're not allowed to make a turn to like go into your driveway. You're not allowed to pass. So you're not allowed to cross the double solid line. So in other countries, you might have one solid line, and that just might mean that you're not allowed to cross. But yeah, so in the US, we have the double solid line. So what can we infer from this? And I've kind of said this already about the model and the view. So in what direction can they talk to each other? Never. Okay, so they can never talk to each other. So these two, here, let's do it this way. These two cannot talk to each other. So model and view don't talk to each other. How do they, if they want to, if they need to be communicating, who will help them? Controller, very good, okay. And then yeah, so we haven't really figured out what's going on here. You might have some opinions or some thoughts here, what might be going on there, but we'll get there when we get there. All right, so, and yeah, any questions here? I think we should probably take a little break here, so let's come back, let's do 10 minutes, let's come back at 8:17. What did we do before the break? We learned about 3 components: the model, the view, and the control. In this case, the view controller. We know that the model and the view should not talk to each other. Why was that? Why shouldn't the model and the view talk to each other? Very good. Very good, very good. So what do they use to talk to each other? The view controller, very good, the controller. So yeah, and then the controller can talk to the view directly, and then the view can talk to the view controller indirectly. There's going to be a couple of communication patterns that we're going to talk about here. So we covered target action already. Today we're going to see delegation as well. What is going on? Here we go. Let me match the color here. So we're going to see delegation. And then, so we've seen this already in Swift UI. So that one is going to be around here and elsewhere. We're going to see callbacks. Okay, so these are kind of direct. And then, so this one is kind of I'm going to put a little asterisk here. So for reasons. And then yeah, so direct communication, we just talk to the thing directly. All right, so anything else here? So we have So yeah, we kind of went through the flow. Button is a view, so it recognizes the user tapping it. To be able to talk to a view controller, we will have had to have painted a little target on there, so the button shoots its little arrow at the target. The view controller will execute some code, likely talk to a model. Maybe the model changes, so now we update the view again, and we can do that directly by talking to the label here. All right, so let's start building some stuff here. So let's kind of redo some of the work that we've done last time for doing the tip calculation. So I think we had a little layout here that we were using. We're going to do this slightly differently with this. So we could, oh, I guess I'm not sharing the screen. So we have a text field. We're going to put that on there. Here we had a picker. We could use a picker, but we're going to create our own little component to do that. We have a calculate button, and then we have a label. So let's match that. So we need a text field. There is dark mode. I had asked, I think last semester, if people prefer dark or light. So yeah, let's see of the people who are here, what you guys prefer. So this is light. Let's switch it to dark. Let's see. Where is it? Say again? Yeah, there you go. Thank you. Dark. Do people prefer this? Anyone strongly opposed? Okay. You prefer the light one? Is it okay? So we're in a little conundrum here. Is it harder to read for you this way? Can I make it larger, maybe? It's fine. Okay, good. Okay, so yeah, interesting. So last semester preferred the light version. Okay, so if you're not too strongly opposed, if you can work with it, then we'll switch to dark mode. Everyone else happier with this? Okay. Also, maybe it's easier if you sit a little bit closer. I don't know. Okay, good. Also, I've had a semester where people wanted all of the lights out. So that I thought was also interesting. And then I think dark mode made a little bit more sense. Okay, so yeah, so let's mimic what we have here. So we have a text field. Let's put a text field on there. Again, we'll just go to the plus button, pick it here, put it up there. Oh, actually, I think I might have. There we go. So we have a text field. Then we have our button. I think the button said calculate. Very good. We have a label that's going to say our, here I'm just going to change the tip. Let's say something about the tip. We, for now, are going to have another label that just, we're going to leave the thing that shows us how much tip there is for later. There is a picker view here. So we could use that one. That one would behave similarly to the, yeah? Oh, yes. This is not a name. This is just the this is the text. So the title label is text. So when I double clicked, this is the title label text here. So name, I guess. So if we were to, we're not holding on to it with a variable that we can access right now. So to do that, to give it a name for our view controller, we would control drag and add an outlet, and then here we could give it a name. But you're maybe seeing where are other things that we can change about this button?
Yeah, because this earlier, right? You changed it to the center resolution any.
Ah.
UI button.
Okay.
And then I see center title label, like that means it's like the UI buttons, like
yes.
The title label would be a property of the UI buttons.
Yes, very good.
See, like,
What other properties are? Very good question. So a couple of things we can do. So one, we could control. So here we're changing this programmatically, right? So we're setting, we're asking for it programmatically. So if we command click the button, we get to the button's interface, and here we can see all of the things that are on there. So all of the methods, all of the properties, but we're also in this visual land here. So let's see how we can see things about the button here. If we bring up the edit menu here, and it's not doing it, there we go. So the third from the right button here has properties that we can change. And so the thing, when I double clicked, it was the, where is it? The title. No, here, calculate. There we go. So that's what I changed for a double. Very good question. Yes. Very good. Yeah, very good question. Yeah. Cool. Okay, so yeah, we have our text field, we have our button, we have our tip here. Before we do anything else, before we redo our work here, maybe something we haven't done in UIKit is make sure that this works on all devices. On SwiftUI, it kind of just worked on all devices. In UIKit, we have to go through one more hoop. And I think I showed this. So right now the preview is for iPhone 16. If I go to iPad, this does not look right. It's all smushed here in the corner. So we want to, oh, they changed that, interesting. I like that better. So yeah, we want to make sure that this kind of works on all devices. So in SwiftUI, everything was just grouped centrally, and then we added padding around it, or between things, spacers and padding. Here, very different way of working. We are creating something called auto layout constraints. So what are auto layout constraints? So if we go here, we are describing relationships between view components. So let me actually draw what we just have, so that we're not drawing any extra stuff. So we want a text field, we want a button for calculate, so say calculate, and then we have a label that says tip. And then I'm just going to give this like a dashed layout. Okay, so we want to describe relationships. So for example, I want to say these two components are a certain amount, a distance apart from each other. Then I want to say the label and this button are a certain amount away from each other. And then I'm going to create a relationship between the top edge of our text field and the top edge of the view, the main view, the parent view in our view controller. And here, so I could give it a width, but then it would look weird again on other devices. So let's create a relationship between the leading edge, and so this one's called the trailing edge. So the edge on the right. So we don't say left edge and right edge, we say leading edge and trailing edge. And the reason for that is not all languages read from left to right, and in those languages those components would be flipped. Leading is the left one, and trailing is the right one. So if you're trailing something, it's behind you. So here, if you're starting to write, this is kind of, I guess, yeah. Trailing edge is at the end. Leading edge is at the beginning. So yeah, we're creating these relationships. Here for the button, if we want it centered in the view, we can say, hey, I want to, so if there's a center line, I want this button to be centered. It's not centered right now, but we'll have it centered. So that's how, and that's maybe, here, let's anchor it to that. Okay. and then same with the I somehow have a different width now. Here we go. We want those connected, or describe. We want relationships between those. So how do we do this? These little relationships that we're creating, they're called auto layout constraints. How do we create them? So we can create them visually. That's what we're going to do today, and then we can also create them programmatically, and we'll do that later. I'm just going to give us as much space as possible. There is also a way to turn this to dark mode. I forget if you guys want. Let's see. I forget where to do that. I think it's here. No, it's not. It used to be. It's one. Oh, here we go. It's here. There we go. Do you guys prefer that? Okay, let's.
As long as I'm not getting blasted.
All right, let's leave it light. Okay, so how do we create these relationships? Let's start with this text field. So if we go back to our drawing, we want a relationship to the leading edge of our view here, and the leading edge of our text field. So how do we do that? Down here, these are the auto layout constraint buttons. So not the very first one and not the last one, but the three in between. So the main one probably that you'll be using is this one. So let's click on that one. And here we can describe relationships. It tries to figure out the ones that you probably mean. So right now these are distances to the top, the leading edge, and the trailing edge. And these are not pixels, so these are points. And the reason for that is different device resolutions have different pixel densities. So we're going with so a point is something that looks equivalent on devices with different pixel densities. So let's do maybe let's do 32 from the top here. So I'll type that in. I don't know if you saw that, but like this little bar became dark red. I don't know if that's was visible. So if you edit these, they become active. Or you can click there, click on it, and turn it on or off. So if I want the 51 here, I can just click here, and it becomes active. But 51 is maybe a little bit far away. I'll do a 16 instead. Oops, 16. And here I'll do 16 as well. So I want the top, the leading, and the trailing edge. And so very often when you're doing this stuff, one thing you don't want to do is create too many of these. So if we, and you want to be predictable and kind of always do the same thing. So we want to, in this case, we don't want to create the relationship between the component that's below us right here. We'll do that when we're clicking on this one. So we're doing leading, top, trailing, and then I say add constraints. And then look what this one's going to do. So I'm going to click that thing, and it kind of snaps into place. And all of these all of these relationships here, all of these layout constraints turn blue. So blue means we are fully constrained. We have the exact amount that we need. So if I remove one of these, clicked on the wrong thing. So if you can select one of these, and if I delete, okay, that's different. That used to be, I think they messed this up. That deletes the whole thing now. You used to be able to select those there. We can still select them here in the view hierarchy. This is so interesting. That definitely is a new behavior. Oh yeah, here it works. Okay. So I selected this one. Now the top bar is red and the bottom bar is red. This means in the vertical direction we are missing a constraint. So if I undo this, so I guess I can bring it back here by saying I want this top constraint, add constraint. So now everything is blue again. So the vertical direction is fully constrained and the horizontal direction is fully constrained. If I get to delete one of these here, no, it just deletes the whole thing. That's definitely a bug. But yeah, so in constraints we have some here as well. We should be able to delete there. That also deletes the whole thing. Interesting. That it didn't behave like that. It didn't used to behave like that. Interesting. But yeah, so blue means we're good. Red means we're not. So the other thing that you might see is once you start adding constraints, that's when you get those blue and red things. So the calculate button doesn't have any constraints yet. So not adding any constraints and adding all of the constraints that are necessary, it kind of works together. But if you're using constraints and you're not adding all of them, then your layout will break when you're building it. So this will build, and it will look kind of like how we are wanting it to look. So let's build that. So yeah, our text field is all the way up there. I can now rotate the device either with up here or command and then the arrow buttons. So if I rotate that, the text field is now spanning the entire thing. These didn't move. These are in the exact same position that they were. So these are not going to adjust to device orientation or size. So yeah, you can mix fully constrained and not constrained, but not only partially constrained. I would always fully constrain, like I would make sure everything is constrained because then everything is predictable. Okay, so how do we do the calculate button now? We could go here again. If we go to the top, it'll figure out the view component that likely you mean, and it'll do that. So maybe we can show that real quick. So I'll just activate this and maybe say 32. Okay, it'll snap into place. Okay, it jumped there. The other thing that you can do, sometimes it's ambiguous which top one you mean. Maybe there's two components right next to each other. Another thing you can do then is highlight or select the view, hold down Control, and then you can describe a relationship by pointing at a view that you're meaning to create a relationship with. So I want this text field, and then I want vertical spacing. Okay, so it created it in place. Very good. And now if I want this edited, if I want it smaller, I can't just drag this component. We'll get a misplaced view. So this one says it is 46 points away from where it thinks it needs to go, so I'm going to undo that. So if I want to edit this constraint, same for all of these. We highlight it, we bring up the editor, and then so if you have a constraint selected, the third from the right, these are the constraint edit properties that we have. So constant is the one that we are interested in here, so let's do 32. And if I hit enter, it'll jump into place. Okay, any questions here? Why is the button red? Like on the right and the left? We didn't add constraints, okay. So buttons are different from text fields. Buttons and labels have an intrinsic width. So if we didn't add one of the leading or trailing constraints for the text field, the view would break. The button works if we're just creating one constraint, either to the leading or to the trailing edge. Let's demonstrate that real quick. We don't need this guy anymore. Let's just create a leading edge constraint, and let's maybe say 16. So it jumped, it's hugging this side here, so this works right now. One caveat with this, so if you're only constraining, same with the label, if the text that you're displaying here changes, or it might change for unexpected reasons, and it changes beyond the device width, the text will just keep growing. So if you want the label or the button here to line wrap, you will also have to create a constraint to the right. And it'll do that. So now if we have a paragraph as a button, then it'll line wrap. It'll create multiple lines. So what might be an unexpected reason for why your text is not the size that you anticipate? Any thoughts? Why might it not be the exact same width that you are anticipating when you're designing it? So let's say we have this calculate button. And it looks, so let's say we'll constrain it to the leading edge again. What are scenarios that you can envision where calculate will go beyond the edge of our view here? So I can demonstrate it with not calculate. 1 second. So see how this goes off the edge. If we create another constraint to the right, 16, it'll line wrap like that. Does that make sense? Okay, but yeah, so just with calculate, it could go off the edge. Can anyone think of scenarios? There's a couple of scenarios that could happen where just the word calculate could go beyond the edge. What are thoughts? Okay, yeah. So maybe, so maybe there's something that we do later that we're not anticipating right now, where the size changes. Very good. Yeah. Any other thoughts? Yeah, maybe something moves it over. Very good. So yeah, I guess also what you're saying with animation. So maybe later we're moving it over. Yeah. Any other thoughts? Okay. So yeah, it could push it all the way down. Yes. So then it'll actually disappear in the bottom here. So to mitigate that, we would have to put everything on a scroll view. So for us to be able to look up and down, there's a UI scroll view that we have here. So we can plop that one down and then put all of our components on there. Very good question. But yeah, can anyone else think of why would this grow in size from what you are predicting it to look? Accessibility, very good. That's a big one. So I think we can simulate this here. 1 second. Where is it? Oh, here. So second from the left here, next to the thing that hides the view inspector, there's a little mannequin that does this. So we can click on that. Turn on accessibility. Let's see if we can make calculate grow bigger. So there is. I thought that was, oh yeah, okay. Well, let's just do this one. So that one didn't quite do it. Let's do bold text. Okay, that did it. So, but then this one went. So I think this one, it won't look like this when we're building it. Let's see. Oh, okay, yeah, well, we can also change it. Here, let's see. We can change accessibility in our device as well. Let's go to accessibility. There we go. Thank you. I just clicked something else before. Okay, there we go. And display size. Let's turn on larger sizes and let's crank this up. Okay, didn't make it big enough. But yeah, so accessibility. It might make it bigger than you anticipate. Can you think of another one? But yeah, accessibility is likely the main culprit. What's another one? There are languages that have longer words. So German is a big culprit for this. So if you're internationalizing your stuff, you're designing for English language, and then German comes along and has a paragraph for a word, and then your layout will look broken. So I would say whenever you can, constrain it all the way that you can. So I would say if you want this centered, constrain it to both directions. And then if it grows, it'll grow down, which is nice. So this is one way to do it. If we know, maybe this is a picture, this button is a picture, so it's not going to get bigger. If we want to constrain it to the center, there's another thing we can do. So let's go back here. Oh, we're changing the accessibility. There we go. Okay, so let's say we wanted constraint to the top, but we wanted constraint to the center. We've done all our constraints with this guy. Let's do it with the next one. We wanted horizontally constrained in the container. So if we click that one, we get a center line, and then this thing is constrained to the center line. So everything went blue again. Only possible because our button has a width that it comes with already. The text field does not. All right, any questions here? Yeah? Yeah. So yeah, I'm not a design expert, but what I've seen designers do is, so one, you create a design and you create a design that is also larger, and then you see how it works with that. Some things you just maybe don't want to change it. You can make it so that they don't change the size. So sometimes sometimes that is done for like graphs when you have to have a like certain number of values. What else have I seen? So often putting multiple components next to each other can cause things to get really crowded. So maybe having things be on top of each other instead of next to each other. So for example, you could have a label that describes what a text field does in front of it. So maybe you can have the label above and the text field below. So stuff like that. But yeah, I'm not an expert. You can probably, yeah, there's probably good articles out there, but yeah, not an expert. Cool. So yeah, we're just missing, very good question though. We're just missing this guy. So let's just go back to this one here. Let's do 16 from the top. Let's see if it picks up the calculate here. Let's do 16 from the left and 16 from the right. Okay, very good. All right, so that all worked. This might grow beyond the screen below. Can you guys think of something that we haven't mentioned that could do this? Happens all the time. Any thoughts? Something comes up from below. What would come up from below? Keyboard, yes. So very notorious, happens all the time. People design their layouts without the keyboard coming up. We have a text field here. So if you click on the text field, the keyword will come up. So to deal with that, you'll have to have things on a scroll view. We're not going to cover that right now, but for this one, probably safe. But yeah, if you have longer screens, you want to put things on a scroll view. All right, so that was probably 90% of things that we'll talk about in regards to constraints. In the past, I used to go into a little bit more depth. So there's like ways that constraints can conflict with each other. That is very frustrating. That can be frustrating. But I mean, again, if you get there, you'll be able to maybe Google it as well. We just don't have that much time to cover constraints in too much depth. We'll revisit constraints one more time when we're creating constraints programmatically. But for now, we have most of the tools for constraints. So auto layout constraints help us make the components lay themselves out independent of device size. All right, any other questions? Cool, so let's make this actually do the calculation. I'm going to do this really quickly because we only have a little bit less than an hour left. So let's put tip here, double, and we said, I think we started with 20%. When the button is pressed, we are going to get the text fields value. Right now, we don't have a way to interact with the text field yet. So we have the output label that we can write to. We're doing that when the button is pressed. And we have the button, but we don't have a way to grab the value from the text field. What do you guys think we need to do to grab the value from the text field to be able to do that? So we say again? Drag click, yes. So let's drag click. And when in doubt, drag click, yeah. So too lazy to come up with a better, let's say, meal amount. There we go. Outlet, we want an outlet. And let's connect it. And now we have a value, a variable here, a property to interact with this text field. So to grab the value from the text field is direct communication. We're going to ask the text field directly. The view controller can do this. View controller has access. It owns this text field here. It's on its main view, so we can ask it questions. And one of the things we're going to ask is, what's inside you? So let's do that when the button is pressed. So let's get the meal. Let's call it meal string. So we have meal amount dot text, and one would think that text would be a string. If we command click on it, we could also option clicked it. It's a string question mark. What does string question mark mean? Optional, yes. Say again. Maybe it's a string, yes. So we're dealing with an optional. Why is this an optional? How could there be not a string in here? So one might think it's when you don't type anything in. That would be a good guess. It gives you a string. It gives you an empty string if you don't type anything in. So when is this nil? When the text field's view has not been built. I can't think of a way that you would actually be able to get to that with Interface Builder. So when does the text field get built? So when viewed load gets called, we have everything built already. So at that point, we're interacting with things. So there's going to be a string there. So yeah, not quite sure how this ever would be an optional, but it is. So what do we do? How do we get the text out of the optional container there? If let, okay, let's do that. So where do we have access to this string now? We have access to it for this duration. Okay. So now we have a string now. Now we have to get this into a double. So let's do that. So if meal double, these are terrible variable names here, but so double, meal string. Okay. So we know that this can produce an optional, so I already put it in my if let here. Okay. So we now have that double if it exists right here. And only here. So not here anymore, only here. So this looks pretty awful to me, these like two nested if statements. If you have another one, it's really hard to see where we are here in the code. So let's take a couple of minutes here to make this a little bit nicer. So the first thing we can do is I don't want anything to happen when this is nil. That I was saying that really never happens. So there's nothing specific I want to tell the user that they need to change. So I don't need this to be two things. So one nice thing that we can do is we can just combine these two unwrappings in one if let statement, and we do that with a comma. And now we are unwrapping both of these with one if let statement. And both of these variables are going to be accessible here if they both can be unwrapped, and if either one of them cannot be unwrapped, we won't go into this block of code. So that's very nice. I find this hard to read. So what I do when there's more than one, I put each of the let statements on one line, and then I put the curly bracket on the next line. I just find this a little bit easier to read. So this is one way that we can do it, and then we have both of them unwrapped. I wanted to show you another way to unwrap, so we don't even have to be indented at all. but I think we're running out of time here a little bit, so we'll do that next week. All right, so if both of these can be unwrapped, so both of these are successful, and we have a meal double here, we can now do our math. So how do we do the math? We have our tip times the meal, and we want that to be in our output string here. Oh, let's do this. Total tip, and then our output text here should have this. So what's the type of total tip? What's its type right now? So we're doing, I heard double. Any disagreements? So that's option. So if I hold down option, it turns into a little question mark. It'll tell us what it is. So it's a double. So we did math with it, and we can only do math with it if both of the things that we're doing math with are the same type. So tip is a double, meal double is a double because we were able to unwrap it. So so this is a double. Yes?
Does it ever auto cast?
Never.
Never?
No.
Okay. So we just flag it as an error.
As an error, yeah. So we'd have to cast it ourselves. Yeah. Very good question. So now we have to get this into the text field. What type is the text field? So it is a string. It is an optional string, but doesn't really matter. So yeah, we can put a string into an optional string. Can we put total tip into the string like this? Can we do that? No. Yeah. So it doesn't autocast from a double to a string. So what did we do last time? We said this is an amount of money, and we don't want to do the formatting ourselves. So we can do formatted, and then we can add, we can say currency, and then we can use the device currency. I think it's, I forget the exact, we have it in the last lecture. So I'll just do USD, which is US dollar. So it'll format it nicely to be a currency, in this case US dollars, and put it to the output text here. All right, so we should be able to do that right now. Okay, so let's do 100, calculate $20. And then, so I guess we wanted to say tip colon, so let's maybe move this to another, so here let's do tip formatted, maybe a little bit easier to read, and then here we can do tip, and then, so we said we could do something like this, where we add the plus sign. Something that you'll see a lot more often than this is where you can put strings inside of, or variables inside of other strings. So the way that works is the backslash, the two brackets, and then you can put a variable in there, and then we could have an exclamation point after the end if we wanted to. So we've also seen this in a previous lecture. So let's just make sure that works still. Oh, 100. Calculate. Okay. Great. What if we make a mistake and put something in that is not a string? Sorry, it's not a double. We can have an else block here, and then we'll use the same output text. And then here we can be helpful. We can say, hey, this thing that you gave me, output.text. So here it'll matter that it's an optional. We'll see that in a second. Is not a number. So what is the error that we're getting here? It is telling us, it's going to use a really dumb error message. String interpolation produces a debug description and not an actual value. So we are trying to output an optional. We know it's not an we know there's a string there. Oh, we have, we don't have it necessarily. So, so one way that we could deal with this is we can give it a default value. So here, let's do, I guess in this case it would have made sense to, oh no, yeah, so I guess in this case it would make sense to keep them both separate. Let's do it. Let's keep them separate. Oh, no, that was right. And then we can use this one. Meal string. There we go. Okay, so, but I used the wrong indentation. There we go. Okay, so if we're able to get a string out of this, which we always will, then we're going to go into this. If we can get a double out of it, we calculate the tip and present it. If not, we put the output there. Since this is now really difficult to read, I'm going to show you the other way of unwrapping an optional. So what I don't like is like nested. Whenever there's nested code, to me it becomes very difficult to read. And the deeper the nesting is, the more difficult it is to read. And also, for me, the meat of the main thing of this thing that should happen is here. This is, I'm going to call this the happy path, the golden path through my function, the thing that I want to happen. So this is the thing that makes that I'm actually trying to calculate. All of the other stuff is, let's make sure that someone didn't put something stupid in there. So I like to have the happy path not be indented at all. So that's one of my goals for making things easily readable and understandable. How can we do that? So instead of unwrapping with an if let, we can say, we can short circuit. We can say, if this is not a string, then I don't want to continue. So it's kind of like this. And then it's a magical place where this string will exist after here. Does that make sense? So we haven't created it yet, but that's what the intention is here. So I want to be able to short circuit. So if this is not a string, I want to return, and then my happy path continues here, and I have access to the string. Does that make sense? How do we do that? So there's another way to unwrap, and so let's keep this guy. There's a guard statement. So guard, and so when you're guarding, so in like sports, if you're guarding someone, you're making sure that they're staying in their place. If you're guarding a palace, you're making sure that no intruders are coming in, and if you don't want them in, you short circuit them out. So you're showing them the door. If you're at the door, someone comes in who's not wanted, you just get them out of there immediately, without bothering the other guests. So let's use this guard statement. So we're going to guard against this being true. So we're going to say this should be true, else return. So what this says is, hey, if you are not a string, get out of here. If you are a string, now this variable is accessible from out here. And it made it so that we can get rid of this entire level of indentation. We could do the same thing with this one here. So the happy thing is the happy path is this one. I really like it when the happy path is not indented. So we could say, let's guard against this thing being a double. So if this is not a double, let's get out of here. Let's return. And then all of this stuff can not be indented. And then in this case, if this is not a double, we can inform the user, hey, you made a mistake. Does that make sense? So with an if-let statement, we wouldn't have access to these properties outside of the scope that's defined by the if-let. Here, we don't have access to that inside the block. So if I try to print meal string, we're going to get a compile time error because this is the thing that wasn't successful. Does that make sense? So a little bit of maybe difficulty at first to wrap your head around. What I really like about this is we can do a bunch of checking. Like we can check 15, 20 things. If we had to do that with the if-let, we would end up maybe with like 15 lines of indentation. This way, the happy path is not indented. So we're at the same scope level as our function, which I really like. Little anecdote, so Swift is now, I don't know, like 14, 14 years old maybe, I'm not quite sure. Swift 1 didn't have the guard statement, and so Swift is type safe when you're trying to work with JSON. So you have to unwrap every property in a JSON thing that you're trying to read. So now let's imagine you have 100 properties on your JSON object. So in Swift 1, you would have had to have 100 indentations to check all of them. So that wasn't very readable. So I think people called them Towers of Doom, or because you were not able to read this anymore. So this was really nice. We'll get to unwrapping JSON later. It is much nicer now. So you still have to, it's interacting with JSON. We're still putting something type safe on there, but it's much nicer now. Yes? Yeah, but yeah, so try catch, you would still have the thing you're trying is still indented, and then I guess oh yeah, I see what you're saying. So a try, but not a catch, right? So you're trying, and then you're handing it off to some other place to catch it, right? It's just an if else statement on its head. Normally in an if-else statement, in an if statement, you would have this be the thing that is true. Here in a guard statement, you have the thing that comes after that's true. Yes?
I mean, isn't guard, like, as in, like, there's a thing called guarding statements, right? Or guarding statements, or something like that. Essentially, it's an if statement, right? That
Yeah.
you usually write at the beginning of whatever function you
Exactly,
have,
yes.
and you're guarding for it, right? So it's like, if anything happens, like if there's an error, it's like saying, hey,
Yes.
I don't want this bad event to happen. I want you to just check for it to happen.
Yeah.
So it's an if statement.
That's it, yeah.
If X is equal to 12, I don't want it to happen, so now keep it strictly less than 12.
Yeah, very good. What language have you seen that in?
C.
C, okay.
C,
I haven't seen that in C. Cool.
Python, or I think it's just like, it is just like, it's a concept, right?
Yeah,
It's,
yeah. So I hadn't seen it before Swift. So yeah, cool. So maybe, yeah, so I guess it's around in other places.
Yeah.
Very good. Say it again, sorry. Oh, the auto tapping. So it's slightly. So there's going to be a thing that we don't know about yet to do that. So we won't do that in this one. So yeah, we'll be able to do that probably after the thing that we're talking about now. But we might not have quite enough time to finish it. But yeah, so right now we wouldn't be able to do it yet. Cool. But yeah, so far we have, except for the auto typing, we're good, right? Like this works, this is great, and then I think we are now also able to, we haven't tested the something is not a number. Let's test that out real quick. Let's mess this up. Okay, so that works great. All right, so any questions here? So we re-implemented the tip calculator. We learned this new way of unwrapping optionals by having the happy path not be indented. Happy path, golden path, those are both things that you might hear places. I think it's a nice way to organize your code, because then if you have this function, you're trying to figure out what it does, you can, if you're not interested in all the edge cases, you can kind of just skip through all of this, like, okay, we're guarding against something, and then the happy path is here. So it makes it much easier to pass if there's like a bunch, if you're trying to quickly figure out what's written there, you can just look at the happy path thing. So I think it's a good standard to do. All right, so let's now do something new for showing our tip, for changing our tip. So what we're gonna do is, let's go back to our, also I owe you another break, I think. So let's do a 5-minute break this time, or 6 minutes. Let's come back at 9:15. Where were we left off? Where did we leave off here? So we wanted to be able to change the tip percentage somehow. So what we're going to do is we're going to add another button. So we're going to move all of this down. I'm just going to squish it here. Oh, I'm just going to squish it here. And the button is just going to show the percentage of the tip. And when we press it, we are going to navigate to a new screen. And this new screen is going to have another text field and a button that says, oh, yeah, maybe it says set tip. And then we'll figure out how we want to cancel this. So, and then it'll pre-populate the, it'll pre-populate our tip percent with what it is already. So yeah, pressing this button gets us here. We put something in, we hit set tip, and then this should update. So that's what we're going to try to do right now. We're probably not going to have quite enough time to finish this, but we'll get there slowly. We'll make some progress. All right. So first thing, let's just add let's do all of the view stuff here real quick out of the way. So I want another button. So let's bring up button. Here we go. Let's drag that on there. I think I want it kind of below the calculate. So let's remove this constraint. Let's have that one snuck in there. Let's have it say, so I'm just gonna say X% so that we know that something's going on here. And so I want all of this to look nice again. So let's control drag to the top. Sorry, not control drag. Yes, control drag to the top. Let's do this one first. So let's do control drag. Let's do vertical spacing. And then let's control drag this one, vertical spacing, and then we can, thank you. That would have taken me a while to figure out what I did wrong there. And then, yeah, so a label, we need to constrain that. Oh, this is not a label, this is a button. Oh, it needs to be constrained to the center. Another thing we can do is we can have it be constrained the same way as the other one. So we can say center horizontally. So now they both have the same horizontal center, which we can do. And then maybe just to cram all of that. Here, let's find the right constraints. Let's do that one and make it. Where is it? Multiply. Oh, not multiply. Where's constant? Let's do 16 again. And then let's find the other one. Where's the other one? I think that's it. Okay, all right. So we have our new button in there. This button is gonna be slightly different. So what we've done so far is we have control dragged our button into our view controller. The other thing that buttons can do is they can get us to another screen without having to interact with the view controller at all. So let's bring up another screen. Let's go to the plus. Let's go to view controller. Here we go. I'm going to drag that one, and I'm going to put that one there. And I want the % button to go to this view controller. So I can now control drag the button to this view controller and say show. And then we have this connection here. We're going to talk about what this is in a second. This arrow means that this is the view controller that will launch when we start the app. This this arrow here is called a segue. We're going to see what segues are in a second. If I move this thing, that arrow will kind of follow it and show us wherever that is. But yeah, so I could say, hey, actually I want you to go into this screen. Then when we're booting it, it would go into this one. Yes, question. It's a new screen. Let's test it. Let's test it out. See what happens. So yeah, maybe try to anticipate how the screen should present in your mind. What would you expect? So I'm going to click on this. So this is a modal. So it pops up from the bottom. We don't have a way to dismiss it right now, so we can slide down to dismiss it. We can also put a button later. Another thing that you might have expected is maybe you would have expected to like have it slide to the side and then be able to go back. If that's what you prefer, we can click this view controller. We can go to Editor and then embed in navigation controller. So this will take both of our, this is our initial view controller that we had. It took both of those. So if I, these were the ones that we had before. Our new entry is into the navigation controller, and then these are owned by this navigation controller. So let's see what this looks like. Okay, so if I click here, now we have this behavior that you are probably maybe were anticipating or expecting to happen here. Yeah. Do we want to go to this page or this page, or? Okay, yeah. So good question, very good question. So here we just control dragged to make this happen. Since we don't have time to do all of this anyways, I'm just going to go with your line of questioning here. And we'll do it slightly differently that can show you how to do that. So we won't be able to completely finish this here today. So let's take your question. It's a very good question. So the question is, right now there's no way to disable this button. There's no way to, so let's say I'm authenticating. This button should not be able to get me to this page here. So right now there's no way for us to do that. So let's remove this. This is called a segue. Let's remove this segue. And the way I'm going to connect these two now, just so that we see that this one's different, I'm going to change the background color to maybe blue, just so that it looks different. And is easily recognizable that we're going to this thing. So now when I am pressing this button, instead of dragging to the view here, I'm going to drag, 1 second. We have to turn this into a, so we have to create this view controller file first. So let's do that first. So this was our tip view controller. Oh, sorry, this is our calculation view controller. Let's clean up a little bit. Let's right click, refactor, rename, and let's call this one, once it's all done, calculation view controller. Let's create another one. New, this got rearranged. Let's do this, file, new file, here we go. Let's call this one, that's also a different behavior. Let's call this one tip, or tip change tip calculator. Change tip view controller maybe. Change tip view controller. Tip view controller. There we go. All right. So let's import UIKit, and then so I don't want to type that twice. So class. We have to inherit from UI view controller. So UIKit does inheritance. SwiftUI does protocol conformance. So here we are actually, this is a base class, so we're inheriting everything from that. SwiftUI doesn't do that. We'll talk about that a little bit more later. Okay, so we have our change tip view controller. I'm just gonna mimic, or I'm just gonna reproduce the other things that this one had. So it had this view.load, and now we have this change tip view controller. Okay, so this thing that we dropped on here doesn't know, we haven't connected it to this view controller yet. So how do we do that? So if we're in Interface Builder, if I'm selecting the view controller, I can assign the code file to this view controller. So I now have to go to the center here. So again, this is on the rightmost thing comes up, the center one, and here it says the class that we should use. And if I start typing, so change tip view controller, it already found it. So we want to use that one. Okay, so now this one has changed its name to change tip view controller, and this one says calculation view controller. So so it changed its name. Great. So the question was, how do we make a button go to this screen under a condition? So we might want to maybe disable this button. We want to maybe send it to a different screen if we're not logged in. So let's create a different kind of segue. We're gonna control drag and oh, one second. Oh, sorry, it's not from that button. Sorry. We control drag from this view control. We control drag from here to this view controller. So what we're saying is there is a way to navigate from this view controller to this one. We haven't defined yet how. So when we dragged the button, we said this button navigates to this controller, to this new screen. If we're dragging from our view controller, we're saying this view controller somehow can navigate to this view controller. Does that make sense? Okay, so let's do that. Let's do a new show segue. And this one we're going to have to give a name. So if we click on this segue, if we go to the third one from the right, it says identifier. So we have to give this segue a name. And sadly, it's a string. We're going to have to type it exactly right in two places, otherwise it doesn't work. If we change it in one place and not in the other, it doesn't work. So let's say this one's maybe called show change tip segue. I've been using the word segue. You might be asking yourself, what does that mean? What is a segue? Were you asking yourself that question? Like, where does that word come from? Maybe you're imagining the little electrical thing that has two wheels, and its inventor rode it off a cliff and died. Have you guys heard this? The inventor of the Segway died riding off a cliff with a Segway, is what I've heard. Not tragic, not funny, but so yeah. So maybe you're thinking of that as the Segway. The word Segway existed before the thing, the electronic device. Have you guys heard the word Segway in conversation? So if you're segueing into another topic, it means you're transitioning to another topic. Same thing here. Segue is a transition from one screen to another. So, and I can never spell it unless I see it. So somehow that word, to my German first language brain, does not compute. Okay, so we have this segue created. Again, we created it from our view controller to this new view controller here. So now we have to make it so if we want this button to perform this thing, great. Somehow we have to now call this segue. For now, we'll use that button, but inside that button, when we're pressing the button, we could do some logic. We can say, hey, are you logged in, or whatever, or was this successful? So here we can write some code to check should we be able to navigate to this, and we can also segue to another screen if we wanted to. So let's bring up the calculation view controller, and let's create a button pressed for that one as well. So now we have multiple button pressed. Let's refactor this one and say, so the calculate one should say calculate button pressed. Okay, let's rename that. Okay, calculate button pressed, much better. And so now let's create a new action now from the percent thing, from the percent button, and let's call this one change tip button pressed action. That's great. So this one, so we had changed this one to sender UI button. We can change it here too. We can just say, oh no, not that one. Here we go. Type any UI button is already there, so we can select that, and then we have access to the button itself. We don't need it for this in this case, but you might want to do that later. All right, so we now have a button. When we have a way to execute some code when this percent button is pressed. Okay, let's now make this segue happen. So how do we do that? The view controller has a function on it that says perform this segue. We can explore all of the functionality that a view controller offers us by command clicking onto the view controller here, and then we can scroll through and read all of the functions that are available here. I know kind of what I'm looking for is, so I'm going to do command F, and I'm going to be so I think it's perform segue with identifier. So this is the one that I want. So let's do that. So perform. So we're doing something on the view controller. So I could say self dot, but it also, the compiler knows that we're inside the view controller. If there's a function that we're calling something on the view controller. So maybe this time I use the self, but most of the time you won't see the self written. So self dot meaning there's a function on the view controller that I'm going to use. Perform segue with identifier. Here we go. Here is the identifier that we have to pass in, and that string has to match exactly what we gave here. I've copied it, so it should just be this, and then sender, we can send ourselves as the sender. All right, let's try it out. Here we go. Let's press the X, and it performs that thing. So now, if you're logging a user in, maybe you're going out to the internet, submitting credentials, coming back with a happy response, you can wait until you have the happy response. So you can have some logic here where you're checking that your internet response was happy, and then you can perform the segue. And if it didn't, you can maybe show an error message or whatever. So yeah, does that answer your question? So if you had to, you could also, depending on maybe a user's logged in or not, you can go to a different screen if you're pressing a button. But that answers your question, right? That you had? Yeah, okay. Okay. How do I separate it? Very good. So what we had before was, how do I maximize space here? Okay. So what we had before was, there was the button. I control dragged the button here. And now it just goes there. So this segue, we don't have to give it a name. When you press the button, here it's so when I select it, the arrow, the button highlights. So this means these two are linked. So what we did now was we went to the view controller, so this bar is the view controller, and if I control drag from up here to this view controller, that means I'm creating a way to transition from this screen to this one. We can have multiple ways to do that. Maybe we can transition to different screens, and I'm picking show as the segue here, and then the key thing to be able to call this segue programmatically is select, and then give it an identifier. And then if I if I recreated everything here correctly, it should do that transition again. Yeah. Okay. So that your question is answered. Very good. Okay. Any other questions? So we have 7 minutes. Okay. So let's. I guess just to see again the layout constraint creation. Let's have this mimic what we have here, and then I think by the time we have that, it'll be the end of the class. And then we'll talk about how. So I guess what problem are we going to face? So once we can get the tip here, what is the problem that we're going to have to solve? Sending the tip back. Yeah. So let's get to the point where we've solved everything. Where maybe we turn this into a percentage when we're pressing this button, and then we can pick up from here next week, and we can talk about how do we send this back. Does that sound good? Great. Okay. All right. So all of this we've already seen. So I'll go relatively quickly here. So let's put a text field on here, and let's put a button on there. There we go. Oh, so there are different kinds of buttons. We've done the plain buttons. Let's do one of these. I think so. The slightly more prominent buttons. I guess that one's blue on blue now. We don't need this one to be blue anymore. Let's use the default. Nope, not what I wanted to do. Background. Is that, I think, background system color. Let's use something less obnoxious. I don't want to find the correct thing right now. Let's do green and not good. Okay. Gray. How about that? There we go. Okay, so yeah, these slightly more prominent buttons, they're often used for calls to action. So a call to action button is the user needs to, so there's some information on the screen, and you're very sure that they want to do this thing. So that you can use these more prominent buttons for them, which is great. Okay, so let's use auto layout constraints to constrain this nicely, and then when we press the button, we'll turn that into a double. So I'm going to have you guys drive. What do we need to do to constrain the text field? Oh yeah, so sorry, more high level. So what do we need to do? How do we make sure that this? What are the? But yes, very good. Bottom right is how we're doing it. But yeah, so high level description. Yes. So yeah. So very good. For both sides. Very good. So let's do that. And then, as you said, down here at the bottom, we do, so let's do 32 to the top, 16 and 16. Those are pretty standard. Add 3 constraints. Button. So we've constrained these buttons to the center just to prevent issues with other languages. We're going to do the same thing here, where we're going to constrain it to the top, and then 16 and 16. We'll see that this one that has a background, it'll be much bigger now. I mean, I'm fine with that. And now let's make it so that this button calculates or gets us the double. So there's one other thing here that you might run into. So we created a new file for the change tip view controller. So we didn't have it in the calculation view controller. if you have two view controllers in the same file, unless they fixed it, you're going to have a very hard time dragging actions into them. So it's very buggy. I'm not sure if it will work eventually, but it just doesn't work very well. So just make sure that each view controller is in its own file, and then we can now bring up the change tip view controller. Let's maybe, here we go. Here's the change tip view controller. And what do we need to do to be able to interact with the button and the text field? What were the steps? Drag, and then so one of them needs to be a outlet, very good. And the other one needs to be a action, very good. Okay, so let's do that. Let's do the outlet first. Oh, not what I wanted to do. Control drag. And let's call this one tip. We want, so it looks like we don't have these connected right now. That can also happen. So if this happens, something broke and we have to restart Xcode. So luckily, UIKit and is just very fragile. Swift UI works much better. So this, it's been so much nicer to work with that. Here we go. All right, let's try again. Control drag, action, and no. Okay, so let's see what, then I might have actually done something wrong. Let's see. It looks like we lost our, I'm pretty sure we had selected the view controller type that it is. Somehow we lost that. So this one was the change tip view controller. So then, there we go. So yeah, the problem was, so the other thing that can happen is, I haven't seen it losing it, so that's new. But yeah, so if you create a view controller file, we want to be able to, we need to connect the code file to the view controller file. So yeah, I guess, so we're at time, I'll finish this at home. We've seen it, so we create an outlet and an action, and then we take whatever, well, I guess, yeah, we'll do it as a review next week. All right, thank you guys so much. Have a good week, and I'll see you guys next week.